Okay, then we'll just move on our next speaker, Dr. Humberto Campins from the University of Central Florida. Can you share your screen, Dr. Humberto?
So today I'm going to talk about the possibility of searching for exogenous material on asteroid Apophis when it comes by the Earth in 2029. This is work that I'm doing at the Center for Lunar and Asteroid Surface Science at the University of Central Florida in Orlando. And my co-authors are Remington Cantelas, Marcel Popescu, Eri Tatsumi, Julia de Leon, Javier Licandro, Danny de la Justina, and Hannah Kaplan. And I'm going to give you a brief outline about the detectability of exogenous material on Apophis and related findings that make that a more likely possibility and why we should look into it. The problem of surviving projectiles. Now we have detected exogenous material on at least 3 asteroids, maybe more. And until now we thought that these projectiles would not survive the impact. Then I'll tell you more about the opportunity in 2029 and leave you with the conclusions. So exogenous material could be detectable on Apophis, and the likelihood of such detection has been increased based on several recent observations that we review in this presentation, and we review its possible implications if they do get detected. The Alma-Ata meteorite, which came from 2008 TC3, contained different meteorite types, different lithologies that came from different parent bodies. And until that meteorite fell, this had been considered an anomaly. But recent results from the Dawn mission, the Hayabusa 2 mission, and the OSIRIS-REx mission suggest that material from multiple parent asteroids is more common than had been expected. Xenoliths, in other words, material that come from a different parent body in meteorites, have been detected in a number of meteorites, including the HED chondrites, which are associated with Vesta, and the ordinary chondrites. And the majority of the xenoliths on these meteorites are carbonaceous material. This foreign material has also been found on asteroid. The Dawn mission confirmed that carbonaceous xenoliths found on the HED meteorites were related to the dark material on Vesta. And I'll show you some images in a moment. And then on NEA's Bennu and Ryugu, the OSIRIS-REx and Hayabusa 2 missions have discovered V-type related to Vesta and S-type related to ordinary chondrite material in these asteroids, respectively. The primitive nature of Bennu and of Ryugu means that this material was not formed with them and is most probably exogenous. So we have then 3 asteroids where we have found primitive material on silicaceous asteroids and bright material on carbonaceous asteroids, respectively. So here's the example of, in the case of Vesta, from the paper of Reddy et al. 2012, and then the exogenous material on Bennu from Kaplan et al. 2019. There's a paper that is under revision by De La Justina with a lot more detail on this. Then in the case of Ryugu, the work of Sujimoto et al. 2019 indicated that these materials would be S-type, so bright boulders on a dark asteroid. In the case of Ryugu would be S-type, in the case of Bennu would be V-type, like in Vesta. So what about the survivability of these projectiles? Until now, the high mean collisional velocity, which is about 5 kilometers per second, had been used as an argument against the projectile material surviving an impact. However, they do, clearly, on Bennu, Ryugu, and on Alma-Ata and on Vesta. So modeling is underway by a group in Nice headed by Patrick Michel, and how impacts can actually yield surviving material on a rubble pile disruption. A reminder that Apophis will be coming very close to Earth in 2029, and This close approach can provide an unusual, maybe unique opportunity to obtain Earth-based and in situ observations. Such observations could reveal something similar to what was observed on Vesta, exogenous carbonaceous material on a silicate surface. So Apophis is an SQ-type NEA, which was likely delivered to the near-Earth space by the Nu 6 resonance, and it's associated with LL chondrite meteorites that contain the Krimka meteorite, which has been known to have carbonaceous xenoliths. So in the case of Apophis, which has a geometrical albedo of about 25%, and the carbonaceous material that could be on its surface would have an albedo between about 3 and 10%, so it would appear dark, like dark spots on a bright surface, kind of like in Vesta. Now, the detailed surface spectra of Apophis, if it's done in situ, could also reveal material that would have a similar albedo, but a very different spectrum in the case of like a V-type spectrum as opposed to an ordinary chondrite spectrum in the 1 and 2 micron region. The implications are that the presence and amount of exogenous material on Apophis can constrain its collisional formational history. For example, exogenous material could, on Apophis could constrain the time it spent on in the inner belt before being sent to the NEA space by the Nu 6 resonance. This could be combined with cosmic ray exposure ages in an attempt to link specific meteorites to Apophis, which would be a very interesting proposition. So in conclusion, we have exogenous material now identified on asteroids Bennu, Ryugu, and Vesta by spacecraft. The close approach of Apophis in 2029 provides a unique opportunity for detailed Earth-based and in situ observations. The presence and amount of exogenous material on Apophis can constrain its collisional formation history and possibly link it to specific meteorites. Thank you.